record. All right, it's 4:56, so let's get started. So last week we spent a bunch of time talking about. Everyone can hear me, right? Just checking. Someone type something in chat, please. Yes. Okay. Great. All right. So last week we spent a bunch of time talking about the historical circumstances behind object-oriented languages, right? We talked about Simula, we talked about Smalltalk, we talked about Self. So now we're going to actually look at a language that you are probably going to use at some point in your careers, namely C++. And we're going to talk about, how we're going to go from the high level, like interface design stuff, to sort of implementation questions, which is like, how is object-oriented dynamic dispatch implemented in C++? It's actually quite involved, and we're going to go through a lot of the particularities in today's lecture. So from whence did C++ come? So C++, as its name suggests, was a extension to the C programming language. And essentially, the idea that Bjarne Stroustrup had was that, hey, C is cool. C is efficient. It's flexible. You can use it to write very low-level programs that, can run basically anywhere, very down to the metal, like a high-level assembler. But that's it, right? Like, you get functions, and then that's it. And then you're sort of on your own figuring out how to, actually structure programs in a higher level style. It's very interesting. Like, when you look at, for example, C GUI frameworks that are written in C, they basically have to re-implement an object system from scratch by themselves because C doesn't give it to them. And, Bjarne was looking at Simula and was like, wow, this object-oriented program organization is great. But I don't want to use Simula because it's very high level. It's got all this random stuff. I want to have a low level systems programming language that also has object-oriented programming organization. And lo and behold, C++ was born. And the sort of big problem, the big design constraint Bjarne had when he was trying to design the C++ programming language was he wanted to add new features, and he knew that when you use these new features, necessarily your programs would have to run slower because there's no free lunch, right? Like, if you want dynamic dispatch, then you actually need to do an indirect jump. You can't just go straight to the function. And so Bjarne's goal was he just wanted to write a language where we had all these features available, but if you didn't use any of them, you wouldn't have to pay for it. That is to say, if you wrote C code in C++, it would run just as fast as if you had written C code. And all the incremental features that you added, you can opt into paying for them. Another way to put for this is everything that we add to C++, there should be a way to directly talk about it in terms of hardware. And so this led C++ to become a kind of interestingly terrifying language. And the reason for this is because C++, when they're designing their features, they want them to be cheap, right? They need them to be free if you're not using them, and they want them to map to reasonably efficient machine level concepts. So the implementation has an extremely important role to play in what features we're going to add to the C++ language versus not. But as a consequence of that, if you have a feature and it could be implemented in a very straightforward way, mapping directly to hardware, but that leads to, sort of kind of icky user visible behavior, like it just does something weird and unexpected because, we just implemented it so that it runs efficiently on hardware, the efficiency in hardware will win. Right, so you'll get the version of the feature that is efficient and kind of hard to understand, and the semantics is going to suffer for that. So C++ features are cheap, but sometimes they're very complicated to understand how they work. So let's talk a little bit about how the basics of object-oriented programming, namely virtual tables, work in C++. We're not going to get to virtual tables yet, but that's where we're going to be headed. So what's going on here? So we've got a bunch of stuff in this slide. So on the top left, I've got my class. So I've defined a class named A. I have some member variables and some methods. The member variables say what is actually stored on the class when I allocate it in memory. So here is an integer A, and then the function, basically says some operations that I can use to operate on the data inside my class. And I am not going to talk about visibility modifiers in this class, although they're a very important part. But by default, when you define a class, all your members are private, and you have to specifically say which ones you want to be public. So this method f would be the only way of interacting with A by default, ordinarily speaking. So okay, we've got objects, we've got fields on the objects, we've got methods. Sounds pretty cool. So does that mean C++ has object-oriented programming? And the answer is, well,